Hello, I'm Dr. Catherine Clements, the Ecology and Natural Resources Educator here at University of Florida IFAS Extension, Sarasota County. And we're here today with the LIFE program, Learning in Florida's Environment. Our special guest today is Miss Juliana. She is going to talk to you guys all about weather, clouds, lightning, and thunder. In fact, there's a whole bunch of clouds up there above us right now. It's going to be so super exciting. So let's go find her and learn more.
Hi, my name is Juliana Costanzo and I am the 4-H Youth Development Intern with University of Florida IFAS Extension and Sustainability, Sarasota County. Through 4-H, we focus on projects and hands-on learning. During this video, you will have a few opportunities to learn by doing the experiments that we show you at home. So, what are we going to talk about today? We're going to talk about clouds, thunder, and lightning. So, what are clouds and how do they form? Well, clouds are a collection of water droplets, ice crystals, and tiny pieces of matter floating in the air that we can see. Matter is all the physical stuff in the whole universe. Matter makes up everything that we can see, touch, smell, and taste. This matter, these tiny pieces of matter, are also called particulate matter or aerosols. Aerosol is short for aerosolutions, and that just means teeny tiny pieces of matter floating in air. That's things like dust, sea salt, and even some hairsprays. Okay, so a cloud is just a mixture of aerosols, tiny water droplets, and ice crystals. Clouds can be anywhere from ground level to 60,000 feet in the sky. Airplanes fly around 30,000 feet. Clouds are really important because during the day, they protect us from some of the sun's harmful rays by blocking them out. And during the night, clouds keep warm air trapped close to Earth's surface, which keeps us from getting too cold. When the water droplets, ice crystals, and particulate matter or aerosols get so heavy because there's so many of them floating in the air that it's too heavy to float, it rains. Let's take a look up at the sky and see the clouds that are there now. Wow, super cool. All right, now let's go make a cloud in a bottle. For this experiment, you will need boiling water, a couple of ice cubes, a glass jar with a lid, and a clear glass jar would be best so that you can see your experiment, and also some aerosol hairspray. Not all hairspray is aerosol, but if it sprays like this, it is aerosol. And then you have the option to get some food dye, which this will help you see the difference between the water and the cloud. It also makes it a little more fun. Okay, so let's begin. First, we're going to take the boiling water off the hot burner, and we're going to let it cool just a bit. We're going to make sure that our clear glass jar does not have the lid on. Make sure you do this with a parent because boiling water can be a little dangerous. Then we're going to put our clear glass jar in the sink, and we're going to take our boiling water, which we should have about a cup of it, and then we're going to pour it in our clear glass jar until about halfway. Perfect. Okay. Now that we've done that, we can take our glass jar out of the sink, and then this is really important to do it. Oh, before we do that, I'm going to add just a couple drops of this blue food coloring. Awesome, super fun. Okay, and now I'm going to take the aerosol hairspray, shake it up a bit, and I'm going to spray it into the glass jar, and immediately after I'm going to put the lid on really fast. Okay, awesome. And I'm going to screw the lid on, and then I'm going to put a couple ice cubes on the top of the lid. All right, and now can you zoom in a little closer, Cassidy, and we can watch as our cloud forms. You might be thinking, how do clouds form in nature? Well, water from the ocean heats up and turns into water vapor. It turns from a liquid into a gas and rises into the air. When it gets high enough in the sky, it's really cold up there, so it turns from a gas, water vapor, back into a liquid. It turns into water droplets, and it also turns into ice crystals, a solid. When those water droplets mix with particulate matter or aerosols like dust and sea salt, and in our case, hairspray, a cloud is formed. That mixing together of the water droplets and ice crystals and aerosols or particulate matter is how a cloud forms in nature. Super cool, right? Next, let's talk about lightning. Lightning is a burst of electricity in the sky. Here's a picture. To understand lightning, first we have to understand electricity. And to understand electricity, we have to understand positive and negative charges. Think of it this way. Everything has positive and negative charges, even you. So within matter and everything that's made up of matter, there are both positive and negative charges. Protons have a positive charge. They both start with the letter P. So if you have a hard time remembering, just remember that proton and positive both start with the letter P. Electrons carry a negative charge. When an object has more protons than electrons, it has a positive charge. There's that letter P again. And when an object has more electrons than protons, that object has a negative charge. When there's the same amount of protons and electrons, an object has no charge. It is neutral. The top of a cloud is really cold. When the ground beneath the cloud is warm, it heats up the air above the ground, and that air heats up the bottom of the cloud. So now we have a bunch of warm particles running around, and then above that we have a bunch of cold particles running around. And when they run into each other and mix together, it causes polarization. And we'll talk about that in just a minute. But what that means is positive charges gather at the top, and negative charges gather at the bottom. So the top of the cloud has a positive charge because there's protons up there, and the bottom of the cloud has a negative charge. So electrons gather around there. So the cloud separates into a positive charge at the top and a negative charge at the bottom. The ground beneath the cloud also builds up a positive charge. So we have a positive charge on the ground, a negative charge in the bottom of the cloud, and a positive charge in the top of the cloud. Positive, negative, positive. All right, and now to demonstrate polarization, which is just the separation of charges, I'm going to use magnets because magnets work in a very similar way. Magnets don't have positive and negative charges, they have north and south poles. However, magnetic fields and magnetism works in a similar way to electricity, and polarization in general covers both of these things, both magnets and electricity. So we're going to use magnets to show you polarization. Magnets have a north pole and a south pole. When two north poles come close together, they push each other away. When two south poles come close together, they also push each other away. When a north pole and a south pole come close together, they attract each other. So when opposite poles come close together, they attract each other. And when the same poles come close together, they repel each other. So now let me show you polarization in these two magnets. So let's put them together and see what happens. All right, and I don't know if you can see this, but I'm really trying to push them together, and they just don't want to go together. Oh, I'm trying really hard, but they really just don't want to go together. So what that means is two north poles or two south poles are coming really close together, and they're repelling each other or pushing each other away. Now I flipped one of the magnets over, and I'm going to put them together again. Let's see what happens now. Did you see that? They attracted each other. They pulled each other together. And that's because opposite poles attract each other. And similar to magnets, opposite charges attract each other. So negative charges attract positive charges, and positive charges attract negative charges. So we have this buildup of negative charges in the bottom of the cloud and positive charges on the ground. And then when the buildup is strong enough, they start flowing towards each other. So the electrons in the bottom of the cloud flow at really fast speeds down towards the protons on the ground. And the protons on the ground flow upwards towards the electrons. And when they meet, that's when lightning strikes. Electrons travel towards the ground at speeds of up to 60 miles per second. That means those electrons could travel from Sarasota, Florida, where we live, to Disney World in less than 2 seconds. If we wanted to drive to Disney World, it would take about 2 hours, maybe a little less. And if we wanted to run to Disney World, it would take us all day, like 12 hours. That's longer than you spend at school each day. So, that big flash of light we see in the sky releases electricity. And electricity is the flow of positive and negative charges. So now that we know that positive and negative charges flow towards each other, we can see how lightning is a huge burst of electricity in the sky. Here's a picture of cloud to ground lightning, the kind that I just described. This is the ground and this is the cloud. And remember, lightning doesn't just strike downward because we also have protons flowing upward. So even though it may look like lightning strikes downward, they actually move like this, and that's how lightning strikes. And now if you look over here, we have in-cloud lightning. So lightning doesn't ever have to touch the ground. And we know that because remember how a cloud builds up both a positive and negative charge? It has polarization, and polarization occurs. So you can have that flow of electrons and protons within the cloud without ever touching the ground. Before we move on to thunder, I should mention that electricity causes light waves, and that's how we can see it. And I will show you how waves work in just a moment. Okay, now let's move on to thunder. So, what is thunder and how does thunder form? Thunder is the sound created by lightning when it strikes. That huge burst of electricity in the sky causes the air around it to heat up really quickly. It reaches temperatures of up to 50,000 degrees Fahrenheit. And I don't know about you, but 100 degrees Fahrenheit is too hot for me. So I can't imagine what 50,000 degrees Fahrenheit feels like. Hot temperatures cause the air to expand very rapidly. And then, after the lightning goes away, the air cools and contracts or shrinks. So that really fast expansion and contraction of air causes sound waves. And that is what we hear as thunder. So, first I'm going to show you how hot temperatures cause air to expand and cool temperatures cause air to contract. And then I'm going to show you what a wave looks like. So let's get started with our experiments. Now I'm going to show you how hot temperatures cause air to expand and cold temperatures cause air to contract or shrink. For this experiment, you will need boiling water, a plastic bottle, like this one, which is a Gatorade bottle, and a balloon, tightly sealed around the top of the bottle with most of the balloon hanging off. You will also need a bowl of ice-cold water. Okay, let's begin. First, we're going to turn off the stove and bring our pot of water off of the burner. That's hot. And make sure you do this experiment with a parent, just like the one about clouds, because boiling water can be dangerous. So what we're going to do is we're going to take our plastic bottle and put it in the hot temperature of boiling water. And watch how our balloon expands. Wow, did you see that? There's the same amount of air in the bottle as there was before. Remember, this is tightly sealed. The reason that the balloon is expanding is because the hot temperatures cause air to expand. Now, let's put it in the ice-cold water and see what happens. Well, it may take just a little bit of time. Oh, there we go. And now you can see how the cold air is causing that balloon to shrink again. And that's because those cold temperatures cause air to shrink or contract. So wasn't that experiment really cool? And now I'm going to show you what waves look like. So remember, that very rapid heating and cooling, expansion and contraction of air causes sound waves. Sound waves travel through the air like this, and then they reach our ears, and that's how we hear things. We can't see sound waves, we hear sound waves. And light waves also travel through the air like this, but they're really, really small, like smaller than a grain of sand. So while we do see light waves, we don't see them as waves. We just see light. And light reflects off of objects and then goes into our eyes, and that's how we see things. So how do waves work? Well, Cassidy, if you'll come on down here and show this bucket of water, I'm going to drop this little tiny crystal ball into the water and show you what a wave looks like. Could you see that? Can you come a little closer? I'm going to bang on the side and create vibrations, which will also show waves. So that's what a wave looks like. And those travel through the air in the form of light waves and sound waves. Here we just have waves in the water. But we also have light waves and sound waves traveling through the air. And that is how we see lightning and hear thunder. Fun fact, lightning and thunder actually happen at the same time. The reason that we see lightning before we hear thunder is because light waves travel faster then sound waves.
Thank you, Juliana. I learned so much interesting stuff about clouds, lightning, and thunder. If you want to learn more about weather, we have 2 other life science shorts, one on how hurricanes form and one on hurricane preparedness. Please check those out. And if you want to join 4-H or learn more about it, visit your local county extension office or website. Thank you for joining us, and I look forward to seeing you at another episode of Life. Bye!